In today's lesson, we're going to be discussing the slope of a line. The slope of a line is the ratio of the rise to the run. You can see it right here. We're going to use an example of wakeboarding. How steep is a wakeboard ramp like the one shown? To find out, you can calculate the ramp slope. The slope of a line is the ratio of the line's vertical change, called the rise, to its horizontal change, called the run. So in this finding the slope, we have a wakeboard ramp, and it has a rise of 5 feet and a run of 10 feet. We're asked to find its slope. So when following our formula, rise is 5 feet, so that would be 5 feet. The run is 10 feet. So the slope is 5 over 10, and as always, we want to simplify it. So the wakeboard ramp has a slope of 1 to 2. To determine the slope of a line in a coordinate plane, you can find the ratio of the vertical change between 2 points on the line and the horizontal change between the points. In the slope of a line, you're given 2 points on a non-vertical line. You can find the slope of m of the line using the formula. M is equal to rise over run, and the rise, it will be the difference of y coordinates over the difference of your x coordinates. And here's the formula: y2 minus y1 over x2 minus x1. Okay, so in our first example, I'm going to plot with you 2 points. The first point will be 3, 1. So as you'll notice on the graph, I plotted 3, 1, my first coordinate, and the second coordinate would be 5, 4. Now, here are 2 points, and we need to determine what the slope is. So we're going to take our formula, rise over run. So I'm going to start, you can start at either point, but I'm going to start at this point, and I'm going to rise. See how many points I have to rise in order to get to my other plotted point. 1, 2, 3. So I had to rise 3, and from there I ran 1, 2. So I have my rise of 3, and then I ran 2. So the slope of this line right here is this right here. Now, if we're going to use our formula for the differences of the y's and the differences of the x's, let me write down each of those ordered pairs. So note how I've written down the ordered pairs. And my numerator will be the differences of the y coordinates. So here's 1 minus 4 is negative 3. And then the difference of my x coordinates, which would be 3 minus 5 is negative 2. Negative 3 over negative 2 will be 3 over 2. Just as you can see as we counted on the graph, the slope for this line is 3 over 2. And it's also using the formula of rise over run with your subtracting of your y coordinates as your numerator, your rise, the difference of your x coordinates as your denominator. Be sure when you take the differences of the y's, or the differences with the x's, you use the same, either the first y or the second y, and then you use them in conjunction with a uniform. Now, we have gone over this in another lesson, but we have 4 different types of slopes here. I'm going to pause this video and we're going to label each type of slope. Okay, so notice this, we have a positive, then a negative, a 0 slope, which means its rise is 0. In that example, 0, 4 is the rise over run coordinates for the slope. And in our last example, it's undefined. When we were to plot that, this example was 7, 0. It has a run of 0, and any ratio or fraction with a denominator of 0 is undefined. So now, we have two examples that we're going to work on. I'm going to pause the video and we'll come back and check our work using the formulas that we had discussed in the previous example. Okay, so I plotted the point, and you can count your rise of your run. We ran a positive 4, then we run. The run would be a negative 3, so negative 4 over 3 is your slope for this line. Then you can do the ordered pairs. You can take your difference of your y's. We can just do 1 minus negative 3, which is the same as 1 plus 3 is equal to 4. And then 0, our x value, 0 minus 3 is negative 3. So the slope of this line is going to be negative 4 over 3. Okay, so now we have 4 practice problems here. We're going to find the slope of the line through the given points using the slope formula. M equals the difference of your y's over the differences of your x. I'm going to pause the video and we'll come back and check our work. So in each of these examples, we have a little work on there. Some of you could just do it in your head. But in number 1, we had 2 minus 7 is negative 5. 1 minus 4 is negative 3. Your rise of a run would be negative 5 over negative 3. Final answer for the slope of those coordinates would be 5 over 3. Number 2, 5 minus 1 is 4. Negative 2 minus 6 is negative 8. Simplify that. The slope of those two sets of coordinates is negative 1/2. Number 3, 0 minus negative 9 is going to be a positive 9. 0 minus 3 is going to be a negative 3. So I have 9 over negative 3. Your slope will be negative 3. If you have a denominator of 1, you just put the slope as the whole number, or the integer. Number 4, 0 minus 8 is negative 8. 5 minus 7 is negative 2. You simplify negative 8 divided by negative 2 is 4 over 1. The slope of these two coordinates is 4. Okay, so now on example 3A and B, we are asked to find the slope of the line shown. So the slope of A would be 0. As we have shown in the previous example. And then in B, we'll take the 2 ordered pairs. Differences of the y's, 3 minus negative 1 would be the same as 3 plus 1. That would be 4. Difference of our x's, 2 minus 2 is 0. We have, and this is known as a undefined slope. You can tell by looking at it on the graph. You can also determine it by the 2 sets of ordered pairs, the relations. Now in these next 4 examples, we're asked to find the slope of the line through the given points, tell whether the slope is positive, negative, 0, or undefined. So I'll pause it and we'll come back and check it. So in these 4 examples, we took our formula, differences of the y's over the differences of the x's, and determined if they were a positive or a negative. So in 5, 3 minus 5 is negative 2 over 2 minus 4 is negative 2. Negative 2 divided by negative 2 is 1, and the slope is a positive. Number 6, 3 minus negative 1 is 4. That would be our y, the differences of our y coordinates, and then 6 minus 6 is 0. So this slope is undefined. 7, the differences of our y's would be 4 minus 4 is 0. The differences of our x coordinates, negative 7 minus 5 is negative 12. This is a 0 slope. And finally, in number 8, 5 minus 1 is 4. 1 minus 4 is negative 3. So the slope of this relation would be -4/3, and it is a negative slope. Okay, in our example 4, we've been asked to interpret slopes as a rate of change. The graph shows the difference traveled by a wakeboarder as a function of time. The slope of the line gives a wakeboarder's speed, which is the rate of change in distance traveled with respect to time. Find the wakeboarder's speed. Now, for this example, I'm just going to use the points 2, 52, and 7, and 182. Now again, we have been asked to find the wakeboarder's speed. So we're going to use the formula of the distance of the y coordinates over the distance of the x coordinates. So if I were to take 182 feet minus 52 feet, then I would take the time of 7 seconds minus 2 seconds. That would equal 130 feet over 5 seconds. And since we've been asked to find his speed, we're going to reduce 130 over 5 seconds to 26 feet in 1 second. So the wakeboarder speed is 26 feet per second. Again, just plotted 2 points on the graph. So I have plotted the points of 2, 52, 7, 182. You try to, in order to determine what an average rate of speed is, as we talked about yesterday, you try to plot out points on the number line that are easy to use. So I just plotted out these 2 points, 2, 52, 7, and 182, to determine what the rate of speed was. So I took the difference of the y coordinates over the x coordinates to determine what the wakeboarder's speed was.